Okay, so this week we were talking about making decisions. So we'll look at a plan of how you make decision logic in a program. What you need to think about as you do it. We'll talk about the if statement, which is the most basic way. We'll talk about the if-else statement, and then there's also the else if as well that we'll talk about. There's switch statements that we'll talk about, and there's nested if statements, there's compound if statements, and there's and or operators you can use as well to make things more powerful. So the idea is to make accurate and efficient decisions in your code. The switch statement is another one. There's if statements and switch statements are the two main ways. And there's conditional operators, there's not operators, there's a whole lot of things you can use to help you out. There's operator precedence. So we talked about BODMAS in last week. And there's also an order of precedence for conditional operators as well, just to make things a bit more complicated. But again, like I said last week, you can just use brackets to make everything a lot easier. And I highly encourage using brackets. So you force Java to evaluate what you want to evaluate first. You don't let Java just apply its rules. Okay. And look at adding decisions and constructors to instance methods. Although we're not quite there yet. Constructors, surely. I think that means constructs to instance methods. Anyway. Okay, so it's a good idea to use pseudocode. I still use pseudocode. After many years of writing code, I still use pseudocode. And it's just about using paper and a pencil or typing your code in. I usually type it in as comments of what I'm planning to do. And you'll see me do it in Jutes as well. So I'll type in some comments. Open the file, read the customers, validate. I'll sort of write comments like that, and then I'll write the code for it. So you'll see me doing that in class quite a lot, that sort of thing. So this is sort of pseudocode. That's pseudocode. It's just any sort of summarized or concise language that lets you plan what you're going to do. Customers, doesn't really matter. Okay, so just concise English for us, and so you plan out what you're going to do, and then the idea is you do it. Once you understand what you want to do in pseudocode, you can then write the code for it. So this open the file here might be, 1 or 2 lines of code. Reading the customers might be maybe 3 or 4 lines of code. Validating the customers, that could be, more code that you add. So you might need to expand these things out. Check their ID is valid. Check their name is not blank. All that sort of stuff. So that's planning out what you're going to do in pseudocode. So it's a very good technique, and I still use it a lot. And the great thing is once you've written it, it becomes comments in your code. Okay, so it is a good thing to do. Just a quick check. Can everyone hear me? Is everything going okay?
Yeah, I can hear you.
Yeah, that's fine.
Yep.
Okay, sounds okay and everything. Yep. That's good. You can also use flowcharts if you like. Flowcharts are a diagrammatic form of pseudocode, I guess. And you've got a series of symbols you can use. Usually the diamond symbol. I've got a flowchart coming up, so I won't bother too much. So they're usually fairly equivalent, flowcharts and pseudocode. The great thing about pseudocode is it's really easy to change. You can just reorder these statements, change them, whatever. Changing a flowchart's a lot harder. Okay, because you've got to maybe rearrange your diagram, reconnect arrows, redraw arrows, all that sort of stuff. So it's a lot harder. So I far prefer pseudocode over flowcharts. Flowcharts are very popular in the 70s, and then they went away especially in the 90s and 2000s. And then in introductory courses, they're sort of making a comeback a little bit, but pseudocode's a much better way to do things. So you can use a variety of shapes as a diamond to represent any decision you need to make. There's the rectangle to represent a process or an unconditional step, and you've got arrows linking things together with yes or no or true and false, and arrows to indicate the directions and things. So we've got a sequence structure, so one step follows another unconditionally, and that's when you've got just process steps following on from each other, and you cannot branch away. So that's called a sequence structure. It's when it's just one step after another, and you can't branch away or do anything different. This is an example of a sequence of steps, and this might be driving to work or driving part of the way to work. So you go west on this road, you turn left onto that road, you go enter onto the expressway, you head south, and so on. So it just shows you the steps you might need to do if you're driving to work. If we're planning it out with pseudocode, we could say everything you need to do in the morning to get to classes. You could get out of bed, brush teeth, have a shower, whatever, get dressed. You might have breakfast and whatever, and then you might get in your car, unlock car, insert key into ignition, turn it. depends how detailed you want to be in your pseudocode, but you could sort of plan out getting to classes or going to work like that. That's just pseudocode, just a series of steps in that case. You could have decisions in there as well. If car won't start, you could call RACQ or call your brother over who's a mechanic, or your sister over who's a mechanic, or something like that, or get some help on the car, try and get it started, or take another person's car, or ride your push bike. So you can have a whole lot of decisions in there as well, depending on how things went at certain stages. Okay, so just planning out what we might do in the pseudocode. So a decision structure involves choosing among alternative courses of action, and it's based on some value or values within a program. And those values could come from user input, they could be read from a file, they could be loaded from a database, just they could be hard-coded into the program, and it's just values inside a program. And all computer decisions are yes/no decisions, so it's either true or false. So if something's true, or if a range of conditions is true, you could take a certain course of action, otherwise you might do something else. And they're used in every computer decision, so very common. So there's an example of a flowchart. So we're going west on whatever road, we're turning left onto this road. Is the expressway backed up? Is there a lot of traffic? Yes, we're going to take an alternate route. Otherwise, no, if the expressway's quiet, we're going to take the expressway route. And you can see by following the arrows that they both join back onto this particular step here and then resume. Okay, so there's an example of a decision happening inside our flowchart there. Okay, based on the traffic, you can go one way or the other. And there could be many of those throughout your code. Is the route across the bridge backed up? Yes, we'll go another way. We'll go through the tunnel. Okay, so there's many options usually. Okay, so that's showing it in diagram form, in flowchart form. You can also do it in just pseudocode as well. This is the expressway. Take the alternate route or take the main route, just depending on whether the expressway is backed up, and then you can resume on with your course. Okay, so that's how you show that same sort of thing in pseudocode. And as you can see, it's much easier to write and draw and things in pseudocode, and you can move stuff around. Diagrams tend to be very hard to change. You've got to disconnect the arrows, and yeah, much harder to maintain. So pseudocode's definitely preferred. So in Java, we do all this with, there's a couple of statements we can use. The primary one's the if statement or the if-else statement. And the if statement's the simplest way to make decisions in Java. A Boolean expression appears within parentheses, or something that evaluates to a Boolean. There's no space between the keyword if and the opening parentheses. I don't know why they would say that. I always put spaces in between my if statement and the opening parentheses, but anyway. Execution always continues to the next independent statement. And you can use a double equal sign. Don't forget to check if something's equivalent. We talked about that in prior weeks. You can't say if age is equal 10. You can't use a single equals. Single equals is for assignment. You've got to make sure you use the right equals, double equals. And I always put a space in there. I don't know why they would say no space, but I always like putting a space in there. Always have. So here's an example of the code. There's a sort of Java sort of code that goes along with this bit of flowchart that we see here. So is this quiz score equal to 10? Yes. We're going to output the score is perfect. Otherwise, we're just going to resume on and do whatever comes next. So this is the code that this comes down to. If quiz score is double equals to 10, system out print line, the score is perfect. So that's the code that goes along with that bit of flowchart. So as you can see, flowcharts are much bulkier, much bigger than the resulting code or the pseudocode that you could write as well. So that's why I much prefer pseudocode. There should be no semicolon at the end of the first line of a if statement. So if you put a semicolon here at the end of that if statement, that ends the if statement. This code here isn't part of it. Okay, that ends the if statement. So this code here will run regardless of what age is. Okay, because you've ended the if statement. So be very careful of your semicolons. That would be an error. Can anyone tell me what sort of error that might be? Is it a compilation error or a logic error? So here's okay. So if I put a semicolon at the end of the if statement, what sort of error would that be? You can type in a chat window if you like. No, it's not a syntax. The compiler won't actually pick it up. A logic error, that's right, it's a logic error. Yep, you're quite right, it's a logic error. If we had this earlier one I showed you, age equal 10, and we had the wrong equal sign there, that would be a syntax error. Java would pick that up and a compile time and say, you know, something's wrong with that statement, basically. Okay. So when a semicolon follows the ifs directly, an empty statement is contained within the semicolon. Execution continues with the next independent statement. Sorry. So if you put a semicolon there, that ends your if statement. So if statement is that long, and this is going to run no matter what. Okay, so you've got to be very careful of your semicolons. So here's what happens with the flowchart when you put a semicolon there. If it's true, you get the perfect score. If it's false, you get the perfect score. You always get it no matter what. So if you're trying to use the assignment operator instead of the equivalency operator, using a single equal sign rather than a double equal sign is illegal. Like I said in the prior lecture, Java will pick it up. If you're using integers or something like that, Java will pick it up. If you're using strings, which we haven't really officially covered yet, but we've done it in the tute, so we might as well talk about them again. And we talked about how string was a reference type. Okay. And if I say name is equal to Mike, even though we haven't done this yet, what it's actually doing here is it's comparing the memory address of this string to the memory address. Java creates a temporary string in memory. And so it's comparing the memory addresses. So they will never be equal. Or will they? Java's got an optimizing compiler and it does string sharing. So if it's stored the string once in memory, it tries to just leave it, store it once. Even if you use it multiple times, it just stores it once in memory. So will they be equal or not? Anyway, that's a question for you, but you've got to be very careful using this to compare strings. Never be equal. And the rule of thumb is do not use double equals to compare strings. One thing we did talk about in prior week was if we had a Boolean there, Boolean valid is equal to true. So we're saying something's valid. And if I say if valid equals false, okay, Java will actually allow this. That won't be a logic error. Okay. But what it's doing in here is it's setting valid to false. And the result of that operation was true. Okay, so whatever code is in here will run always, no matter whatever value valid had, it will always run. It's setting valid to false, and continuing on. So Java won't actually give you a logic error for that one, or a compile error. So no compile error, which is a bit of a shame, but we're still doing a lot better than C++ and C. This one didn't give you a logic error or syntax error in C++. So maybe it will in later compilers, but not the compilers I used to use anyway. Okay, so Java is still looking out for us a little bit, but not for this case. It will allow that, which is a logic error, but it won't give us a compile error for it. So in other words, the rule of thumb is be very careful. Use equals, single equals for assignment, and use double equals for equality. You can use the standard relational operators to compare values of primitive types. Okay, so if we had an age of 10 up there, so you can use equality operator says if age is less than or equal to 10, then you could do something. And of course, these are all lowercase ifs. Sorry. And you could say if age is greater than 10. Okay. And if you wanted to say not equal to, you could say if age is not equal to 10. Okay, so I've used the exclamation point there to say not equal to. So there's some of the equality operators we looked at briefly last week. So it says you can use the relational operators to compare values of primitive types, but not objects or not reference types. So again, with strings, you can't say if name is less than Mike. Okay, you can't do that. And do not use less than, equal to, greater than equal to, not equal to, and all that with strings either, or any reference types. The only other reference type we've done so far is the dates we talked about briefly. We declared today's date. So you can't use any of those operators with reference types. There's special methods you need to use. Okay, so if you use those operators on reference types, then you're actually comparing memory addresses. You're not comparing the values. So you're comparing the memory address of name, or you're comparing the memory address of a date, and it's not going to give you the results you expected. Okay. So you can have a single if statement to perform an action. You can have a dual if where you're performing two possible courses of action. You can use an if else to perform alternate courses of action. And it goes on from there. So you can have nested ifs where you've got if statements inside if statements. You can have compound ifs where you've got an if clause or an else, or an if clause where you've got multiple conditions all joined together with ands and ors, and so on. So we'll talk about all those sort of things coming up. So an if else statement, a statement executes when the if is true or the false. So it goes either in the if part of the branch or the else. For example, we could do that with the age. So we'll go system.out.println, you are older. System.out.println, you are 10 or younger. Okay, so with the else there, if age is less than or equal to 10, we could print out a message, you are younger, 10 or younger. Else, we could print out another message, you are older than 10. It's a good idea to vertically align all your code. You'll see me, I'm very fussy about my code as I'm writing code. It's a good idea to indent your code inside the if statement and inside the else as well. I've put a semicolon there and a semicolon there. Okay, so watch your semicolons. Don't put a semicolon there after that bracket. Don't put a semicolon after the else. Okay, just end of the statements inside the if statements. It's illegal to use the else keyword without the if. So if I just try and do this, that would be a compilation error. So you've got to have an if, an else. Sorry, you've got to have an if you're going to use an else. They're going to match up. And if I try and do this as well, this would be an error. So you can't have if else and then something else, whatever. That would also be an error because I've got an if and two elses. That's not allowed. Depending on the evaluation of the Boolean expression following the if, only one resulting action takes place. So it's either this branch takes place or that branch takes place. If you've got an if else, it's one or the other, not both. Okay, so if this condition is satisfied, whatever that is, this branch takes place, and then execution resumes down here after the if statement. Okay. Otherwise, if that condition isn't true, it runs whatever's in the else, and this runs, and then execution resumes after the else statement. Okay, so it's one or the other. So here's an example of a little bit of code. If quiz is equal to 10, you got a perfect score. Else, no, it's not a perfect score. And there's a flowchart to go along with it. So is quiz score equal to 10? Yes. You got the output, the perfect score. False? No, it's not. And then resume on with whatever's below this, whatever's in here. We're resuming on down here. So this might be just a small part of a program. To execute more than one statement within an if or an else, you need to use your curly brackets. Okay, so if we had multiple statements in here, and you've got to be careful. System.out.println. So you've got to be careful. This statement here is part of the if statement. That belongs to that if. This statement here is not part of it. It will always execute. Okay, so if you've got multiple statements inside an if statement, this is not part of the if. So this will always execute, no matter what value age it's got. Okay, so if you want to have multiple statements inside an if statement, you need to use your curly brackets. Okay, so this is now part of the if statement. And if you've only got one line of code in the else, you can leave the curly brackets out if you like. I like putting them in. If I put them in one place, I like putting them in all the branches. And that just makes your code nice and neat. You can see that things are self-contained. Okay. And also indentation doesn't mean anything. Like with everything we've done in Java, you can have it like that if you like, or like that if you want. Indentation doesn't mean anything at all. It makes it nice and readable for us, so we do like indentation. Okay, so use curly braces if you have more than one line of code in an if-else branch. Okay, any variable declared within that block is local to that block. So we talked about scope last week. We talked about class scope and method scope and global scope. And so any variable declared within this block of code here is local to that block, just like we saw last week. So let's do that. So scope, we'll extend our scope discussion a little bit. Let's say we declare int we're keeping track of the number of people that are less than 10 or 10 or less, and we declare a counter in here and we add one to it, and we try and system dot print line down here. And of course, it doesn't exist by the time we get down here. It only exists from that line of code there where it's declared until a closing brace. So keep an eye on your scope. If you wanted this thing to work and keep count of all the people, you'd have to move it up here a bit to before, and then you could use it down here. That would be okay. Okay, but if it's declared inside here, then it's only valid until that closing brace. Okay. So keep your scope rules in mind. They're very important. We'll keep building on them as we go. There's a lot we need to learn. So any variable declared within a block is local to that block. So any variable declared inside here is local to that block. Any variable declared inside here is local to that block and is gone when we get to that closing brace. If it's declared in here, it's gone when we get to that closing brace. And if it's declared up here, I'm assuming we're in an opening curly brace up there somewhere. By the time we get to this closing brace down here, it's gone. So count no longer exists when you get down here. Keep your scope rules in mind. Okay, so here we've got multiple lines of code in an if statement, or it looks like they should be because they're both indented, so it looks like they're both supposed to be part of the if statement, but there's no curly brackets. So only that first line of code there is part of the if statement. This second one runs all the time, no matter what. Okay, so there's a flowchart to go along with it. So if the hours worked is greater than a full week, we're running this and we run that as well. And if it's not greater than a full week, we're still running the overtime pay. So that's, the employees aren't going to complain. We're still going to get overtime. Everyone's going to get overtime, so no one's going to complain. But the poor company's going to go bankrupt pretty quick, maybe, if they're paying everyone overtime when they should be. Okay, so just watch your curly brackets. If you've got multiple lines of code, put your curly brackets in and watch your semicolons too. Very important. If you put a semicolon there at the end of that if statement, Java won't give you an error. It'll just, these lines of code here aren't part of the if statement. They're just completely different, completely separate from the if statement if you put a semicolon there. Be very careful. Nesting if statements. That's when you got an if statement within another if statement. Okay, and so if you've got an if statement like this, I'll grab this one. And if suburb or postcode, let's do postcode. If you've got a 4700, then you are in Rocky or Rockhampton. It's got a range of postcodes there. Of course, it's got to be double equals. Got to be careful. Double equals. You're in Rocky, and 10 or younger, and then we could say else you are not in Rocky, but you are 10 and younger still. Okay, so that's got a compound if statement there. We've got an if statement with another if. Okay, now does this all count as one line of code? Okay, so if I take off the curly brackets there, will it still work? And that's something you can try if you like, but I recommend just putting on the curly brackets. If you've got an if statement within another if statement, or a for loop in an if statement, or something else we're going to do later on inside an if statement, put your curly brackets in. It's just better to be safe than sorry. Okay, because if you leave your curly brackets out, remember Java doesn't care about indentation. What does that else belong to? Does it belong to that, or does it belong to that? And if this else belongs to that, what's this one doing? Okay, so that's why it's better If you've got nested statements, put your curly brackets in, and it just saves all the confusion. Okay, so curly brackets, braces to prevent confusion. And by confusion, I mean our confusion and also the compiler's confusion. Java might not know exactly what you're trying to do. Pay careful attention to the placement of the else clauses. Else statements are always associated with an if on a first in, last out basis. First in, last out basis. So that answers the question I posed. If those if statements are left, if those curly brackets are left out, that else would be associated with the if statement on a first in, last out basis. First in, last out. Okay, so that one there's the last one out. That one has the next one out. So this else would be associated with that. Okay, you still would be careful. It's best not to worry about that, just put curly brackets in. Okay, so here we've got a nested if statement. If the number of items sold is greater than the minimum items, greater than equal to minimum items, that's true. And the total value is greater than equal to min value, and that's true. Then you get a sales bonus, so that'd be nice. Otherwise, if any of those conditions is, well, if that condition is false, you don't get a bonus, or if that condition is false, you don't get a bonus. Okay, so if that one's true, and that one's false, you don't get a bonus. You can have both true to get a bonus. And here's the code to go along with it. So if the item sold is greater than equal to min, and if the total value is greater than equal to min, then bonus equals sales bonus. Okay, so you can see there's no curly brackets there. I would probably put the curlies in, especially on that first if, and that nested if would be contained within the curly brackets, but you don't need to. It's pretty clear what's going on here. Okay, that's nested ifs. You can also use logical operators to have multiple conditions, and that's called compound if statements. So the logical operators we're mainly talking about are 2 ampersands, and that's and. So double ampersand means and in Java. Double vertical bar means or. So you've got to make sure you get the right vertical bar symbol there. It's the one above your enter key, shift, the shift slash key above your enter key. Got to make sure you get the right one. Okay. You can join conditions together with those now. So we could say if age is equal to 10 and postcode equals 470, then we could say you're younger and then Rocky. Now you've got to be careful with your brackets here. Java doesn't actually care about these brackets. You can take those inner ones out and you've got the outer ones. But you'll see me when I'm writing code, I've got to put brackets around the inner stuff as well. So I'm going to go, so that's okay. And I'll show you, but I'll show you the way I write it. I put inner brackets and then I'll put an outer bracket as well. So I do that condition and that condition if they're both true. So if they're both true, that's double ampersand means and. So if age is less than 10 and the postcode is to Rockhampton, I can say you're in Rocky and 10 or younger. 2000, let's do a Sydney one. You are in Sydney. So everyone's starting to feel a bit involved. I'll do a Melbourne one next, I promise. Okay. So either of those are fine. You can just put the outer brackets, but that looks so strange to me. I've got to put the inner brackets as well. I'm a bit fussy about my code. So both expressions that surround the operator must be true before the action in the statement can occur. So if that's true and that's true, then you're from Sydney and you're 10 or younger. Okay, there's a flowchart to go along with that. So instead of having the nested if statement here, we've got the compound if statement here, or the compound conditions. If item sold is greater than the minimum, I thought that was equal to before, greater than equal to. Yeah, it was greater than equal to before. Anyway, it's greater than now, it doesn't matter, whatever it is. And the total value is greater than equal to min value, then you get a sales bonus. Okay, so you can do it with a nested if statement or if statement structure, or you can do a compound if statement. The OR operator is double vertical bar, and that means if either condition is true, you can the if statements are executed. What's in the body of this statement is executed. So let's look at that. So we'll do a Melbourne one, and we'll use double vertical bar. And can anyone guess what we would say there for the message? So if age is less than 10, less than equal to 10, or postcode equals 3000. Assume that includes 3001 and 3002 and 3003, and all the Melbourne postcodes. Okay, so what would we say? What would we say here? It'd be Melbourne. We still say and 10 and younger, or would we say something else? Yes, that's right. Or 10 or younger. So you're either from Melbourne or you're 10 or younger. Okay, so anyone who's in Melbourne would get this message, and anyone who's age 10 or less would also get it. So if either condition is true, you would get that message coming out on screen. So quite right. Well done, Jared. You were quick on the draw then. You got in before anyone else. Righto. So that's ends and ors. You got to be careful. You use the right one when you mean to use the right one. If you want all the conditions to be true, it's and. If you want all the conditions, any of the conditions to be true and this to be executed, then it's or. Okay, and it doesn't have to be just two conditions either. You can have multiple conditions, or you have another postcode, or postcode equals 2000. Okay, so if it's less than 10, all the postcodes 3000, all the postcodes 2000, which say you are either in Melbourne or Sydney, or you are 10 or younger. So one of those conditions is true, and down here we don't know which one. We're just saying one of those conditions is true. You're either in Melbourne or Sydney, or you're 10 or younger. Maybe all three are true. Maybe all two are true anyway. Maybe you're less than 10 and you live in Melbourne, but you'll still get that message. Okay. So there's an example of the code for that. If the item's bought is greater than or equal to min, you'll get a discount rate. Else, if the item value is greater than min value, you'll get a discount as well. So there's two ways to get discounts. You can buy over a minimum threshold of values of items. So you might have to buy 10 items or something like that. Or you've bought over the threshold of value. So you might have to buy over $100 to get a discount. So if any of those conditions is true, you get the discount. Okay. So you can do it with separate if statements, if structures like this, or you can just use a compound if. If items bought is greater than or equal to the min, or the item's value is greater than or equal to min, then you got the discount. So that's much cleaner, isn't it? That single if statement there is a lot cleaner than this, which is a bit messy. And there's a flowchart to go along with it if you want to follow that through. Okay. Yeah, we'll talk about short circuits. We'll also talk about, you've got to be careful. If statement. I'll put the age there for now. So here we've got if year is less than equal, if age is less than equal to 10 and the postcode equals 3000, or the postcode equals 2000. So what does that mean? If age is less than 10, so is Java going to evaluate that? Or is Java going to evaluate that first? Or is it just going to work from left to right? Okay, so you can get yourself in a real pickle here with when you've got mixed ands and ors. So my advice would be to put things in extra brackets, put extra brackets in. Okay, And I quite like leaving a space before that last one as well, so that I know that belongs to that one. So that's forcing Java to do this part first, and then do that part, and then and those two together. So it gets the result of this expression: are you in Melbourne or Sydney? And then it ends it on with are you less than 10 years old, less than or equal to 10 years old. Okay, so if you've got mixed ands and ors, please use brackets. To remove ambiguity and force Java to evaluate things the way you want. If you don't put the extra brackets in, if you leave those out, that one and that one out, Java will still evaluate things, but it will apply its order of precedence. And ands and ors have got different orders of precedence. So it'll apply its own internal rules. And if you're from a different programming background, like in C++ or something, Java's rules might not fully match your rules you're used to. So you might make assumptions and make some code that's not quite right. Okay, so it's always better to use extra brackets. Please use extra brackets. Okay, oh, short circuit evaluations. So Java is an optimizing compiler. So let's say you've got a whole lot of conditions here. If age is less than 10, or postcode equals 3000, or siblings is greater than 5, or whatever. We might have a whole lot of stuff being evaluated here. Java employs short circuit evaluation. It's an optimizing strategy by the compiler. So if these are all conditions here, if it finds that this one's true, it just goes ahead and runs that code straight away. It doesn't even bother checking the rest. It's found one that's true, and all the others are ors. So it goes ahead and runs that code automatically. So that's called a short circuit. It can speed up your code enormously by doing that. So that's all built into Java. There's nothing you need to do. It's automatically done by Java. It's automatically done by Java's optimizing compiler. So if that condition's true, it doesn't evaluate any of those. If that condition's false, but this condition's true, then it doesn't evaluate any of the other ones. It just goes ahead and runs whatever this code is. Okay, so in other words, as soon as it finds a match, a box it can tick, it just goes ahead and runs the code. So that's good. It's something you don't need to worry about when you're a programmer, really, but it's just something that Java does for us automatically. Making accurate range checks. So range check is a series of statements that determine whether a value falls within a specific range. Java programmers commonly place each else of a subsequent if on the same line. Within a nested if-else statement, it's most efficient to ask the most likely question first and avoid asking multiple questions. That's a bit of a strange statement there. Well, we'll talk about this. It's more efficient to ask the most likely question first. Let's say it's really hard to work out that condition, but that one there's a lot faster. Okay, so we're better off switching those two, putting this one first. Okay, and also if most of our data is not in postcode 3000, but there's a lot of people that are age 10, we want to put that condition first. So you can actually speed things up a lot in your program by putting the easiest conditions to evaluate first. You can also put the ones that are most common first. If your data's outside of postcode 3000, put that there, so you don't have to worry about evaluating all the other conditions in the clause. Okay. If most of the data has siblings less than 5, or siblings, if very few bits of data have siblings greater than 5, put that first. Okay, so put the easiest ones first to evaluate, and put the ones that are most common. You know, in other words, we can rule out the most of your data. You know, so. You're trying to force Java into evaluating one condition or maybe two conditions and then knowing that the if statement's not going to happen, rather than forcing Java to evaluate 20 conditions and then finding out one's not true. Okay, so trying to just help Java out there a bit. And Java can't really help with that because it doesn't know what your data looks like. Okay, so it doesn't know that this one's going to be the best one to put first. Okay, because only the programmer really knows that because they know what the data looks like. So Java cannot help with that. Righto, so let's so ask the most efficient questions first, and put the ones that are going to rule out most of your data first as well. So you can if only 5% of your data, 5 out of 100 people have siblings greater than 5, put that first. Okay, can help your program process things a lot quicker. Okay, so if the sales limit equals the high limit, greater than equal to the high limit, we get a high rate. If the sales rate is greater than equal to the median limit, we get a medium rate. If the sales amount's greater than equal to less than equal to the low limit, we got the low rate of commission. So just working out the sales commission based on your sales volume or sales amount. Okay. So here you've got to be very careful. That's been done here with separate if statements. You've got to be very, very careful. It looks reasonable. If sales amount is greater than equal to high limit, commission rate equals high. If sales rate is greater than equal to medium limit, commission rate equals medium. So because that's two separate if statements, if our sales amount is greater than high, it's still greater than medium, so we'll end up with a medium rate commission, which the salespeople won't be happy with. Okay, so that should be an if, else if, else if. We haven't done an else if yet, but you can have an else if, whatever. You might have multiple bits of code going on in there. That might be, then you might have an else if, all these conditions are true, whatever they might be, ands and ors. There's some code going on in there to do that processing, else if. You might have another bunch of conditions in here, and a bunch of code inside that runs when those conditions are all true. And then at the end, you might have an else, or you might not have. You don't have to have an else if you don't want to. Okay, so there's nothing that happens down here. You can leave the else off. But it's quite common to have it like that. So if, else, if, else, if, else, if, else, if, else, you can have as many else if as you like. And eventually, maybe at the end, you'll have an else, but that's optional as well. You can leave that out if you don't need it. Okay, so if we apply that strategy to this, that'll be much better. That'll be an if, that'll be an else if, that'll be an else if. Okay, so it's else space if. Not all one word. One word's wrong. It's got to be else space if. It's most efficient to ask questions most likely to be true first, and that's what we're talking about up here. So the conditions that you're most likely to get true, well, that's going to rule out the bulk of your data. Put those first. So if most people get the low commission, say, because it's really hard to get a high commission, companies don't want to make it easy, too easy for you. So if most people get the low commission, maybe we should evaluate the low one first. Medium might be most next common, so we'll evaluate the medium, and then we can evaluate the high. So just switching things around, you can make your code a little bit more efficient if the vast bulk of the people get the low rate. Okay. If the vast bulk of people got the high rate, you could put the high rate first and do the high rate, then medium rate, then low rate. And here they've used a nested if statement, but we could also use if, else, if, else, if. That's another way to do it as well, a bit neater. Areas of beginning programmers, they use and operator when they mean to use or. So if pay rate's less than low and the pay rate's greater than high, so you're trying to say both of those are true, which can never happen, then you're going to get an error. So we should be using your or operator there. So just keep an eye on your ands and ors when you're using them. If you use a single ampersand or pipe to indicate the logical and or, you can do that as well. So if you use a single ampersand there, that's got a different meaning, different effect. logical ands and ors. We'll talk about those more later in the course. Okay, the switch statement is an alternative to a bunch of if statements, and you can test the value of an integer, and with Java 7 onwards, you can use strings in the if statements as well. So they're becoming more and more powerful as Java evolves and is developed. So they're becoming more powerful. And so you can use integers, characters, really, but just integers basically, or string values. And they're being expanded again lately. So there's keywords, there's a switch statement keyword, and that starts the structure. And that is followed by test expressions enclosed in parentheses, and then you got case statements to follow along with those. There's a break command that exits the switch structure. You'll be careful to use those. I'll show you what happens when you don't use those. And there's a default keyword as well, which can be used when none of the cases match. So you might have case 1, case 2, case 3, and a default. And if it's not case 1, case 2, or case 3, then the default code executes. So it's a little like an else at the end of an if else sort of structure. So here's an example. We're doing a switch on year. It's an integer. So case 1. So it's got if year's got a value of 1, we're going to see freshman out on screen. If it's 2, they're a sophomore. If it's 3, they're a junior. It's invalid year. Okay. So if year's got a value of 0 or anything greater than 4, then it's going to have invalid year there. Now, what if we left out the break statements? Notice there's a break statement here, another one there, another one there, another one there. If you accidentally leave off the break statements and it's year 1, so we've taken all the break statements out, assume we've done that. I'll do it with a. So we've taken that one out, we've taken that one out, we've taken that one out, we've taken that one out. And imagine the year is 1. What would happen? Can anyone have a guess of what would happen if we had year at 1? Please type it in the chat if you like. I know it's a lot to type, but okay. So we'd actually see on screen, we'd see freshman come out. If year was 1, we'd see freshman come out on screen. Then we'd see sophomore, then we'd see junior, then we'd see senior, and then we'd see invalid year. Okay, so it just falls. If the breaks are missing, the once one case is found to be true, all the other cases execute and the default. Okay, so you got to make sure you put your breaks in. If they're missing, and that case, say we had that break in, that break in, that break in, but that one there wasn't there. If it was case 4, we'd see senior followed by invalid year. Okay, so you got to put your breaks in for everything. Don't need to put them in for the default because that's the end of the structure anyway. Okay. Still got 15 participants. That's good. Thanks for everyone staying with me and being patient at the start. If a break statement is omitted, the program finds a match for the and the program finds a match for the text variable. All statements in the switch statement execute from that point forward. So you don't need to write code for each case. You can evaluate char variables and strings as well. And you can also do things like uppercase and lowercase and stuff like that. There's a whole bunch of things you can do. Why use switch statements? Well, they're a little bit more compact than a structure like this. Okay, so a little bit more compact. You use only when there's a reasonable number of specific matching values to be tested. If you had if you had to write a switch statement with 3 million case statements, there's a better way to do it. So don't use a switch structure or an if statement. We're going to go on to find out about loops soon. So if you had lots of conditions, like 20 conditions or 30 conditions or more, there's probably better ways to do it. So if you only got 5 conditions to evaluate, perfect. Use a switch structure. The conditional operator. Okay, so this is a bit of a shorthand in Java, and other languages as well have it. It requires 3 expressions separated with a question mark and a colon. You might see this sometimes. It's not very often it's used. I tend not to use it. But it's a nice little thing when you're, in some cases, because it can shorten your code a bit. So you've got a test expression here followed by a question mark. Yes, that's right, it's a question mark. Followed by what happens when it's a true result with a colon, followed by what happens when it's a final result, or what the final result would be if it's false. Okay. We don't have an example. Okay. I'll dig out some examples for you in a tube. Okay, but you basically have a test expression here, which is a lot like an if statement with a question mark at the end, and then you have a test, what happens when it's true and what happens when it's false. I'll dig out some examples for you. I won't interrupt the lecture, we're running out of time. A Boolean expression is valued as true or false. If the value of the test expression is true, the entire condition expression takes on the value of the expression followed by the question mark. So if that's true, whatever that is, in fact, I'll just show you an example now. Yeah, well, that's the sort of thing it's going to be. Age is greater than 10. And a true result. I don't know why you would have those values, and you might have something as well there, but it's basically coming out of that is you're going to test expression followed by a question mark, and then a true result and then a false result. So it's basically coming down to that sort of thing, but I'll dig out some better examples when we've got time. No real time now. An advantage of using it is it's compact. It's a concise statement. Not many people use it, but it's concise if you want it. The not operator is a vertical exclamation point. And it negates the value of the result of any Boolean expressions. So you could say if age is less than or equal to 10, or you could say if not age greater than 10. Okay. That's the same thing. So if not age greater than 10, or you could say if age less than or equal to 10. Sometimes it's clearer to write your code with that. Not in this case, but sometimes there are good reasons to use a not operator. And we'll look at those later on, like when we're processing files and things like that. Okay, so not used super often, but it does come in really handy sometimes. Statements with an operator can be harder to read. They can actually be much cleaner to read as well, depending on what you're doing. And they tend to require a double set of parentheses. So you end up with this sort of thing. A little bit ugly, but anyway, come on to those later as well in the course. You can combine as many ands and or operators as needed in the one statement. And then there's an operator's precedence, is how an expression is evaluated. The order agrees with the common algebraic usage. Arithmetic's done first, assignment's done last, and the and and or operator evaluated, and the and operator is evaluated before the or operator. And then statements in parentheses are evaluated first. So this is like expanding our BODMAS we talked about in prior weeks. And again, like I said, the best way to avoid all the complexity of this is just use brackets. Use inner brackets, then inner brackets around that, and then inner brackets around that to force Java to evaluate things the way you want. Okay, so it's best not to rely on those. So there's the order of precedence for things we've done so far, or part of those. There's logical not, that's the highest precedence, so that gets evaluated first. Then multiplication, division, and modulo operator. Okay. And then addition and subtraction. Relational operators get evaluated next, then equality, and then logical ands, then logical ors, then the conditional statements, then the assignment operator, and so on. So you can see it's quite complex. Why not just use round brackets to force Java to evaluate things you want in the order you want? Much better. Two important conventions. The order in which operators are used makes a difference, and always use parentheses to change precedence or make your intentions clearer. Always use parentheses. That's a golden rule. And that one there's always. So here we've got ands and ors mixed together. So what does Java do? If we go back to our table here, It's ands before ors. So this is evaluated first. Okay, that might not be what you want. That might not be what you're expecting. So if you want this part to evaluate first, put brackets around it. Okay, so it's always better to use inner brackets anyway. So adding decisions and constructors to instance methods. We haven't done constructors yet. Helps ensure that fields have acceptable values and determines whether values are within the allowed limits for the fields. Okay, so we haven't done actually anything like this yet. This is all brand new code for us. I mean, we did do it in the cheat, but that's just me jumping ahead to show you what was coming. We might not talk about this in today's class. We might talk about that more in the cheat. We're running out of time. Basically, we've got a class here where we're storing two types of data, or two bits of data, an employee number and a pay rate for each employee. We've got some constants here, or actually not constants, public int, public double. So there's some public data here with values. That should have a final in front to make it a constant. Public final int, public final double. This is called a constructor, and this is automatically run when we create an object of type employee. Okay, we haven't done these yet. This is all new. Get number and set and get pay rate. So these are called accessor methods or getters. They're just getting the values of these private data items. Get employee num returns the employee num. Get pay rate and returns the pay rate. We haven't even really done methods yet, so this is jumping miles ahead of where we are. Okay, but you can see the point I wanted to raise is inside this constructor, which is run when the employee is created, we've got some if statements to make sure the data is valid. That's the point the code, the slide was trying to make, is that you can put if statements inside methods to validate code when things are created. That's all it's trying to say. But this is all advanced code for us. We haven't done constructors or accessors or anything like that yet. We haven't done any of those. Haven't even done methods yet. So really just look at that part there. When an employee is created, these if statements are run to validate the employee. That's all you need to remember. Okay, so there's some slides there of doing it and don't doing it. So have a go at the code yourself. And sorry about the slow start to this lecture. Gosh, it was frustrating for me. It must have been terribly frustrating for you. Thank you for staying with me and joining in. To avoid hassles next week, I recommend we start the classes 30 minutes late. Okay, so at 10:30 for the lecture. We might try starting Friday's shoot. We'll try starting that on time, so we'll start that at 12 noon. And if there are lots of classes starting at 12 noon and we can't connect, we might talk about starting at 12:30 for future weeks. That's only a maybe. Okay, so we'll start at 12 noon, see how we go. Okay, but I apologise for the massive dropouts at the start of this class. So we'll start next week's class at 10:30, and we'll start the shoot at 12 noon and see how that goes. And maybe in future weeks we might have to start a little bit later. Future weeks, maybe. So we'll see how we go. We'll start at 12 noon. Anyway, thanks for your attention. Thanks for joining in. For everyone who joined in on chat and type comments, thank you so much. Have a lovely day and have a great week and stay safe. Thanks, everyone.